This is another factoring section. This is factoring trinomials 5.2, so let's get started with it. And so they remind us, and this is how you're going to check to see if your answer is correct, about multiplying in chapter 4. So when we saw something like this, we FOILed, right? Remember when we were going to multiply, we FOILed. The first, x times x is x squared, minus 12x, number first, variable second, plus 1x. I can write the 1 or I can choose not to. 1 times 12, so it's positive times a negative, negative 12. And then combining like terms, I get x squared minus 11x minus 12. And in the factoring section, they're going to ask us to go backwards from this. So they're going to ask us to start with this, and they're going to ask us to go backwards and say that this is our answer. And there's a lot of different methods, and I'm going to show you one, and I'm going to tell you that it's okay if you use another method that you learned someplace else, or another method that you groomed YouTube and found. It's fine. It doesn't matter to me at all. Just to see, when you multiply here, the first, you get x squared. You multiply the outer, you get minus 6x plus 2x and minus 12. And again, when you combine like terms here, you get negative 4x. So this method that I'm going to show you kind of takes advantage of something that I hoped you noticed, which is that when you FOIL, the adding happens on the middle terms, but the first and the last are the way they are, right? 1 times negative 12 is negative 12. That was the last. 2 times negative 6 is negative 12. X times x is x squared. So when I go trying to build x squared, well, how can I build x squared? Well, by simply putting x in both binomials, the first term in both binomials. So if I have x squared, all I have to do is put x for the first term in both binomials. And if I have negative 12 at the back, then there's some choices of what I could put. I could put 1 and negative 12. That works to give negative 12. I could put 2 and negative 6. That works to give negative 12. And there's actually other things that would work to give negative 12, but negative 12, knowing that this is negative 12, limits those choices down to a very few. So there are some choices, but not a lot of choices. So there's only one way of making x squared. That's x times x. So you put it in there. And there's a couple of different ways of making 12. 1 times 12, 2 times 6, 3 times 4. But we'll be able to use other information to come up with which one of those it is. So the strategy that I like to use, I call unfoil. I'm sure that I didn't name it. I'm sure that other people call it unfoil. But it's just to go backwards from foiling. Other types of methods I've heard of are diamond couple, hot box, muscle man method. What are some of the other names? There are just tons of them. AC factorization. The names go on and on and on. And I don't care. Why I use unfoil is that I find that everyone loves FOIL, and so why not just go backwards from it? So the factoring strategy is, first step is always factor out the greatest common factor, if there is one. If there isn't, then you don't factor it out. Then you count the terms, and if there are 3 terms, it's a trinomial, and you ask yourself, is it of this form? And we're going to learn how to factor another form of trinomial. So this is the variable squared, and then the variable, and B stands for a number, and C is a number. And so actually both of these met the form. Now you might be saying, wait a minute, there's not pluses in between these, but they met the form because the B was negative 11. And so that you could have written it like this, x squared plus negative 11x, right? And then the plus, and then the C was negative 12. And I don't write it like that, but just so you know. So it is of the form, okay? And so same over here. You could redo that if you wanted. So the B is negative 11 and the C was negative 12, but I don't worry about it. It's of this form. This could be a plus or a minus, and this is a number and that's a number. You write it in descending order with the lead term positive. And I'll show you how to do that. I'll have one that has not in descending order and not the lead term positive, and I'll show you how to make that happen. Then you make the first work. And the good news is that's easy. It's x times x. Then you make the last work. And there might be a few ways of doing it, like there was for negative 12. And so, but you list them out. Then looking at that list that you have, you find a combination that makes your middle work. And if you have plus c, then they're going to have the same signs, both positive or both negative, and they're going to add to the middle. And if you have minus c, which we had here, minus 12, so minus c, then they're going to have different signs, one positive and one negative, and they're going to subtract to give the middle. And then if you can't find a combination that works, it's called prime. And so if there's no combination that works, you've tried all of them, it's called prime. And to start off, I list all the possibilities, even though there's people who factored before that will tell me the answers right away. And so they're asking me to factor this. So my first thought is there a greatest common factor? I'm getting rid of this dull pencil. Other than 1, right? Because if it's 1, you do nothing. And it is 1, right? Because the smallest number up there is 1. And your greatest common factor cannot be bigger than your smallest number. And then they don't all three have x on them. So the greatest common factor is 1. And that means do nothing. Maybe you even sing a song. Okay? Then you count the terms. 1, 2, 3. So that's called a trinomial, right? So I notice it's a trinomial. So I make sure that it's of the right form, which it is, x squared plus 7x, that's our bx, plus c. So it's of the form. It's in descending order. And so what I do is I go through unfoil. And how I do unfoil is I start by making the first work. So I think what two things would multiply together to give x squared? Well, it's x times x. And there's no other possibilities. Then I think about what are the possibilities that would multiply together to give 10. And so there's more than one possibility, but there's not a huge number. 1 and 10 and 2 and 5. And then this tells me right here, this sign, if it's add, it tells me that you're wanting to add to get the middle. And so do either one of these sets add to get 7. And I'm going to show you that the x is working. So I know that it's 7x, but the x, I already have it. You might not see that I have the x, but trust me just for a second. Yeah, 2 and 5, when you add those, give 7, right? So what you put down here in the first places are x and x. I want these both to be positive so that they make positive 10. And when I add them, I get positive 7. So I want this to be positive 2 and positive 5. And I want to show you that even though this I could see made 7 when I added, I want to show you that it was really 7x, even though you might feel like, well, it wasn't 7x. So when you check your answer, so this is my answer. There it is. When you check your answers, the first thing that you do is you FOIL it together to see if when you multiply it, you get back to the start, right? What you started with. So I'm going to FOIL this together. X times x is x squared. Yep, I made that work. Plus 5 times x plus 2 times x. So see how it was 5 and 2, but it was really 5x and 2x? Because what did the 2 and the 5 have to do? They had to multiply by the x's that I had up there. But I wasn't really worried about the x working. I wanted to make sure I had the 7 working and see how 5 and 2 are what makes 7. And then the last, 2 times 10, 2 times 5 is 10. And so, yes, it does work, right? So smiley face, it works. Great. The other thing that you want to check in your checking is that if you have binomials, that it won't factor further, right? And so that this binomial has a greatest common factor of 1. And so binomials, you want to check that any binomials that you have are done. And what it means to be done, it means that their greatest common factor is 1, right? So that's what it means when they're done. So the number is 1x. So the biggest thing they could have in common, the greatest thing they could have in common is 1. And if they have 1 in common, it's done. And same here. And so we have 1 in common, it's done. So we are done. Okay. So, and I'll show you how we'll catch ourselves. We'll make a mistake on purpose on one of them and catch ourselves out there. Okay, so we're going to give a try to this. We can see that our first step is greatest common factor. And I hope that you can see that the coefficient of 1 here and they don't all have a y, that the greatest common factor is 1. And that means do nothing. So you go on to the second step, which is to count the terms. 1, 2, 3. It's a trinomial. It's got 3 terms, right? And how I factor a trinomial is that I make sure that it's in the form, and it is, right? The variable is y instead of x, but that's okay, right? Y squared, y to the 1, y to the 0, so it's in the form. Doesn't matter what the numbers are, doesn't matter if they're positive or negative, it's in the form. And then I tell myself, okay, yes, it's in the form, unfoil. So I go and make the first work. And the good news is there's only one way of making y squared, and that's y times y. And I'm thinking about things that multiply together to give 6. 1 and 6, and 2 and 3. Multiply together to give 6. No other things. And this says they're going to add to get the middle term. And so I want to pick the set that adds to give me 7, right? And in fact, I know that it's negative 7, but I worry about that just right now in a second, right? So now I'm going to worry about that. So it is 1 and 6. And now is when I say, oh, in fact, I didn't really want it to be 7. I wanted it to be negative 7. And what this being a plus says is it tells me 2 things. It tells me that you add together to get the middle, but it also tells me that they are the same sign. So they might be both positive, or they might be both negative. And on this one, they were both positive, is what they were. Because when I wanted to multiply them together, I wanted to get positive 7. And the only way that could happen is if they were both positive. They're both the same, right? So if you want positive. If you want negative, then they both have to be negative. And so this guy actually says, yeah, they're the same as me, is what he says. Yeah, they're the same as me. They're both the same. They're the same as me. And so it tells me 2 things. It tells me add, and it tells me that my numbers are the same sign. And so I get that information. So they're both minus. So I'm going to fit this in here. And I have to tell you that I don't usually foil these to check to make sure they work, because I feel like I've really given a good check to them. When I multiply those together, I get positive 6. Negative 1 times negative 6 is positive 6. When I add these together, since they're both negative, I get negative 7, right? And so I really feel like I've already checked it. And if you're wondering, well, it's negative 7y, but when you do the outer, that's going to be y times negative 6, which is negative 6y, and negative 1y makes negative 7y. So the other thing to check, not only do they FOIL together, right? Y times y is y squared, and minus 6y minus 1y is minus 7y, and then positive 6, right? So not only when you FOIL them, you get what you started with, but the greatest common factor here is 1. and the greatest common factor here is 1. So I'm all done. Okay, so we did a lovely job on that. So we have a few more problems to do here. We'll give a try to it. So I told you that I would show you one that was out of order. And they didn't have a lot of them, so I made one up. And so here's one that's out of order. So you can't help but notice right away that, well, usually x squared would be first, right? And so when I write it in order, negative x squared plus 7x plus 44. So the leader, the highest exponent, goes first. So that's x to the second. This is x to the 1 goes second. And then x to the 0 goes last. That's descending order. And now when I say, is there a greatest common factor? Well, there isn't besides 1. But you notice that I have a negative leader. Negative leader. And so when you have a negative leader, what you want to do is you want to factor out a negative. And in this case, I'm factoring out negative 1 because they only have 1 in common. And so anytime that you have a negative leader, factor out a negative. If you only had 1 in common, factor out negative 1. If you had something else in common, like 2, factor out negative 2. So I'm going to factor out negative 1. I'm going to put the negative 1 here. I'm going to get x squared. Now, negative 1 times x squared is negative x squared. Negative 1 times what would make positive 7x? Yeah, a negative times a negative makes a positive. And so this is just going to change the signs. A negative times what makes a positive? Well, a negative. So we just factored out the negative leader. And now I'm going to ignore it while I factor this trinomial. That is just the greatest common factor. And it just comes along for the ride. I'm going to put it right here, negative 1. And that's going to be in my final answer box, right? But I'm going to ignore it, right? I haven't lost it. I put it in the final answer box. And now I'm just going to factor this trinomial because now I'm on, so step 1, the greatest common factor was negative 1. Step 2, count the terms, 1, 2, 3. It's a trinomial. Monomials are done. The negative 1 is a monomial, so it's done. And it's of the form, right? X squared, x, no x. So it's of the form. Just want to make sure of that. And so I'm ready to unfoil. Of course, you don't have to write your thoughts. I write my thoughts so that you know this is the things that I was thinking about. So to make the first work, because that's what you do in unfoil, you make the first work, you make the last work, you pray the middle works. So x times x makes x squared. Trying to think of things that multiply together to give 44, like 1 and 44. But subtract, right, because that says two things. I'm going to have some room and have what it says. It says subtract to give the middle. And it's so nice that it's a subtract and gives the middle. And those don't subtract to give 7. Those subtract to either give 43 or negative 43, depending on where I put the sign. And 2 and 22, they don't work either, right? Because when you subtract them, you get 20. But I wanted 7, in fact, negative 7. 3 doesn't go into 44, but 4 does 11 times. When you subtract 4 and 11, you get 7, and so it's like hot diggity dog. And this also tells me not only is it subtract, but you're going to have the signs. They're not the same when it's positive. The signs are the same. The signs are one positive and one negative. They're opposite of one another. So all I have to do is figure out which one would be positive and which one would be negative. So coming in here, if I said that the 4 was negative, just for a second, and the 11 was positive, then when I combine those, 11's bigger, and I would get positive 7 for the center when I combine them, right? And so I don't really want that. I want negative 7, so it must be the 4 is positive and the 11 is negative. And this sign, it says the bigger, just like me. So of your numbers, 4 and 11, 11's bigger, the bigger is negative, right? So now we're going to fit this stuff in here. X goes in the first spots, and in the second spots, plus 4 and minus 11 in the second spot. And so when I multiply that together, that ought to give me what I started with. So I can FOIL this together to make sure, right? And so I can check it. I don't have a lot of room. I wish I would have given more room here. Make myself a note. So I'm going to check my example right there. I'm down here on the bottom, and I'm going to check it. How you check it is you multiply it together. So there's 2 steps to checking, and the first step is just to multiply it together. So this time, and you can multiply it in whatever order you like, and I multiply it backwards of where I factored it. So this is the last thing I factor, so that's the first thing I multiply together. X times x is x squared, minus 11x, plus 4x, minus 44. Then I combine like terms here, right? And so you can even use your calculator if you needed to. I got like a dozen calculators here that I could use. Not a single one of them a TI, but that's just me. I'm told Andrea that I was going to get a TI this weekend, so maybe I will. So I do get negative 7 for that center. So I have x squared minus 7x minus 44. And don't forget I had the minus 1. So this is now times negative 1. So when I distribute here, I'm going to get negative x squared, and I'm going to get positive 7x, and I'm going to get positive 44. And I can see that, oh, that's what I started with, except for it was 44 first, 7x second, and minus x squared. So it is definitely what I started with. Then the second step that you check is all your pieces are done. Monomials are done, right? So you check each piece. Is each piece done? This is a binomial, and so does it have a greatest common factor other than 1? If it has 1 as its greatest common factor, it's done. Well, its greatest common factor is 1 because the number here is 1. The number here is 1, doesn't have x in common, and so I checked no greatest common factor, or no, greatest common factor equal 1 in binomials, right? And so it wasn't that there wasn't a greatest common factor, that it's 1. And so you don't have to worry about it, and it's 1. So this was my thoughts in checking it. Okay, and we're going to try this one. This one's in order, and it has 2 variables, right? And it's in order according to a squared, so that's degree 2 for a, degree 1 for a, degree 0 for a. But it's got the b's, and so is it of the form? And the answer is, yeah, we can kind of think of it as still being of the form. And so let's give a try to it. So the first step is greatest common factor. Well, this has a 1, a coefficient of 1, so they can only have 1 in common, and they don't all have an a, and they don't all have a b. So the greatest common factor is 1. My second step is it's a trinomial, and it's kind of double of the form, right? A squared, a, no a, and then backwards, b squared, b, no b. And so, yeah, this is of the form. I'll put a smiley face. We're going to be able to make it work in the form. And so we're going to try to use unfoil. So this is another type that it will factor, the unfoil. So good news, to make a is just simply a times a. To make b, 8b could be 1b times 8b. See how that makes 8b squared? And I know it's negative 8b squared. I don't worry about the sign. Just at this moment, I don't worry about the sign. And you're free to go worry about the sign if you like. I worry about it in a second. And 2b and 4b. And this says it's going to subtract to get the middle. It also says that the signs are one positive and one negative. Okay, and so if I subtract the numbers, I'm gonna be faithful that the A and the B will work out. Okay, and I'll show you that it does work out. But if I just work with these numbers and I subtract 1 and 8, I either get 7 or negative 7, depending on where I put the plus sign and where I put the minus sign. Well, that's not what I want. I want 2. So this set doesn't work, right? How about this set? Does it work? These are the only possibilities to give 8. So if this did not work, then we would say that it's prime. But this is going to work, right? Because when you subtract those numbers, you can get 2. And in fact, I know I want negative 2. And so that's where the signs come in, right? This says the bigger like me. So our bigger is 4. So the bigger is minus, and the smaller is plus. And now all we have to do is fit this in. A and A in the first spots. And plus 2B and minus 4B. And so you put those in the last spots. Now it doesn't matter what order you put them in. So if you had put them in A minus 4B and A plus 2B, yours is exactly the same as me. And so in the back of the book, they're not going to list it both ways. They're just going to accept that you know that they're equivalent to one another, that they're exactly the same. Okay, so we did a lovely job on that. I want to check it. And so either one of these are the answer. I think I can fit my check in here. It's not as bad as that one over there. So when I check it, I just want to show you that you do get the middle term, which was AB, right? Because when you multiply A times A, you get A squared. When you multiply A times minus 4B, alphabetical order, numbers first, minus 4, alphabetical order AB, plus 2, numbers first, in alphabetical order AB, and minus 8b squared, 2 times b, and minus 4 times b, right? So the numbers 2 times 4 is 8, and b times b is b squared. And now I'm looking at this, and I'm saying, well, hot diggity dog. Remember, I wanted negative 2ab in the center. And that's exactly what I have, negative 4 plus 2, right? I only focused on the numbers, negative 4 and 2, and I had confidence that the variables would work themselves out. But now I'm checking it to make sure. Now the reason the variables work themselves out is because these multiply together to really give the middle, right? So that's how I get the AB that I was wanting for the middle. So it's not a bad idea to check until you see, oh yeah, it's going to work, because then it really reinforces, that it works, right? And then no greatest common factor, right? The number here, coefficient, is 1, so they can only have 1 in common unless they have a variable in common, which they don't. So you always need to check that the greatest common factor is 1, right? And so I'm checking that, and right here it's 1 as well. The coefficient is 1, so the greatest common factor for the numbers could only be 1, and the variable, they could have a variable in common, but they don't. Okay. And this one here, and so I hope that you've hopped ahead and that you're trying to get it factored. It is no greatest common factor. That's first step. Greatest common factor is 1. So that means do nothing. Second step is to think about what size it is. And its size, you can count the terms, 1, 2, 3. It's a trinomial. And I can see that it's in the form. And so I try unfoil. And so, I'm thinking it's going to work, right? Y times Y. And 1 times 1, that's the only way. And when I add those, right, this says it's going to add to get the middle. It also tells me something about the signs. But that's when I notice, well, I'm not getting what I thought I was going to get. Because when I try to add to get the middle over here is 1. And that's the number, right? I know it's Y. But the number is 1, and so am I getting 1 when I add these? No, 1 plus 1 is 2. So and there's no other way of making two things that multiply together to give 1, two whole numbers. And so this is prime. It just doesn't work. And I think in this section of the book, I think they put cannot be factored. And that means the same thing as prime. Cannot be factored is vocabulary for prime. And then I think in section 5.5, they say, hey, we got this word for you. It's called prime. And it means it cannot be factored. And so I think that's the story on those. Anyway, just so you know, if you're looking at problems and you look in the back of the book and you encounter something along those lines, then you'll know that that's the story on that. Okay, and then this is problem 64 out of your textbook, and I can see that the coefficient of x squared is 1, so the greatest common factor is 1. And yes, we're going to do one that has a greatest common factor other than 1, and I lost it. I don't know where it went. I think that we were supposed to pare down our things and then have people do things in class. I think that's where it went, and so I think I assigned it for class. So but we'll do it right now, don't worry. And so it is a trinomial. We'll do it next, right? Trinomial. And it's of the form. So we're going to give a shot to unfoil. So you try to make the first work. It's in descending order, x times x. And I'm trying to think of things that multiply together to give 2,000. But when I subtract them, right, because this is saying subtract, but when I subtract them, I get 190. And obviously, if you couldn't think of it, you could go systematic. But the minute you think of it, then you stop, right? Well, it's not 1 in 2,000, right? Because when I subtract, since this is a subtract sign, it tells me subtract. When I subtract, I get 199, right? Not 199, 1,999. I missed 1 9 there, but it's not 190. That subtract didn't look very much like a subtract, but that tells us what we're going to do. And I know it's not 2 in 1,000 either, because when I subtract those, that's 998, right? Which is not 190. And I don't believe 3 goes into 2,000. I'm going to check, just to be sure. No, it doesn't. So how about 4? And so I'm figuring out how many times 4 goes into 1,000. 2,000. 500 times. But when I subtract those, it's not 190. How about 5? Well, how many times did 5 go in there? 400. And when I subtract them, I don't get 190. I hope you've already found the answer, right? But this is how you would go if you couldn't find it, or you couldn't think of it, or you weren't particularly good at multiplying. You could go systematic, right? And so it would take you maybe a little longer to do it, but it's still possible. 6 doesn't go in, 7 doesn't go in, 8, I believe 8 does go in 250 times, but when I subtract those, I don't get 190. 9 doesn't go in, but 10 does, and 10 goes in 200 times, and now all of a sudden, when I subtract those, I do get 190. So even though there's more things I could check, there's no reason to go check anything else. I found what works. So there's no reason to go check, does 11 go in there? Does 12 go in there? Does 13 go in there? Does 14 go in there? Does 15 go in there? It doesn't matter if they do or they don't, because we already found the answer. And so the next one that goes in there actually is 16. And so, but it doesn't matter because I already found the answer. So there's no reason to look any further, right? And so this tells me subtract. It also tells me the signs are 1 positive and 1 negative. And this tells me the bigger one is just like me. And 200 is bigger than 10. So it's negative 200 and positive 10. So this would be x plus 10, x minus 200. And then that's the answer. Okay, so we did a lovely job on that, and we still have some room right here, and I, for some reason, didn't have one, and so I want to make sure that I do have one, and so this is out of your book 38 on section 5.2, the section we're looking at. 5r cubed plus 45r squared plus 100r. So the very first step on every problem that you're asked to factor is to come up with the greatest common factor. And no one needs to tell you that. If you read the directions, they said, hey, there's a greatest common factor. But no one needs to tell you that there's a greatest common factor. It's the first step, is to look for one. And I see, well, the smallest number up there is 5. So they could have 5 in common. And so let's see if they, and that's something other than 1, right? And so let's see if 5 goes into 45. Yeah, it does. And does 5 go into 100? Yeah, it does. So they have 5 in common. This is the biggest number they could have in common, 5. And then they could have an r in common. And I see that every term has an r, and whatever the smallest exponent on the r is, that's what they have in common. So r to the 1 is what they have in common, because r to the second is bigger than r to the 1. So 5r is what they have in common. So what you do with the greatest common factor is you put it in the front. And then I'm going to build this back. 5r times what is 5r cubed? Well, 5 times 1 is 5, so I don't need to write the 1. And r times r squared, because you count them, 1 r out there. I need 2 r's in here to make 3 altogether, so r squared. 5r, this is a positive, times a positive is a positive, right? And 5 times what is 45? 5 times 9 is 45. And then r's, you can count them. I need 2 altogether, so I need 1 here and 1 here to make the 2, right? So 9r. And then 5 goes into 100, right? So a positive times a positive here is a positive. And 5 goes into 100, I think 20 times. I think that's how many times 5 goes into 100. So 5 times 20 is 100. And then I need 1 r, right? I need 1 r. I already have 1 r, so I don't need any more r's. So now I'm on, the monomial is done. So monomial is done. So in my thoughts, I think monomial done. But the trinomial, right? Trinomial, 3 terms. How you might factor it is, since it's in the right form, right? So my form, as you might use unfoil. Or if you are a person that likes diamond couple, you might use diamond couple. So you ignore the 5r. Now you don't ignore it forever. You put it over here on your answer line. So this is the line where I'm going to tell people this is my answer. So my answer has a 5r in it. I don't know why I have that like that, but oh well, I do. It doesn't matter. I centered my 5r on my line as opposed to putting it at the beginning of my line. I don't think it matters, right? So now I'm ignoring it, and I'm focused on this trinomial. I'm ignoring it because it's a monomial, and monomials are done. And so I'm focusing on this trinomial, and I'm making the first work, r times r. And I'm thinking, how can I get 20? And you might not even write down 1 times 20, because you know that that doesn't add to be 9. That adds to 21. And you might not write down 2 times 10, even though that makes 20, because when you add those, you get 12. And 3 doesn't work, because 3 doesn't divide 20 evenly, but 4 and 5 do work, and they're the hot setup, right? And I'm hoping that as you get better at them, that you're saying that right away. I write this for people who are like, what the heck? How did you get that? How did you know it was 4 and 5? Well, I did it systematically. I started with 1 times what is 20. Then I went to 2. Then I went to 3, but 3 didn't go in there. Then I went to 4. And then pretty soon your mind will get where it's pretty good at the multiplying, and we'll know. Remember, this needs to add, right? And that added to 21, so it didn't work. This added to 12, so it didn't work, but I wanted 9. And this adds to 9, so I'm like, hot diggity dog. And then remember, when this is an add, the signs are the same. Signs are the same. They're either both positive or they're both negative. And this guy says they're just like me, right? It could even say the bigger's like me because they're the same, right? I like to only say the bigger's like me when it was a subtract. And so I like to say they're both like me. And so they're both positive. And so then how this part will factor is r plus 4, r plus 5. And then that's just going to go here on my line. Monomial first, binomial second. Monomial goes first, and the binomials go in whatever order you want to write them in. So I want to write them in that order. That's fine. You can choose to write them r plus 5, r plus 4 if you want. But the monomial, we all have to agree that it goes first. 5r goes first. That's the convention. And so we did a lovely job on that. Okay, so that was marvelous. And I think now we have done one of every type that is down there. And we've done more than one of some types. And so that's that story. Stop recording.